in this case, what I was doing was just a fun little scientific hobby. I realized on a vacation trip that you could figure out the flight speed and the turning radius of birds flying around in circles, just soaring in circles like you see a hawk do, a turkey vulture, by noting the time to do a turn and estimating the bank angle at which the bird was operating. From those two numbers you can immediately calculate the flight speed and turning radius, and you can do it with essentially no tools, just your wristwatch and estimating the bank angle. You have to write a formula and use a little calculator for it. So we were doing this on this vacation trip and comparing the black vulture with the turkey vulture, which flies slower in smaller thermals and can take off earlier in the day when the thermals are smaller. And you begin being more interested in how one bird compares with the other. And then I found myself thinking about, how does this compare with a hang glider? Can it fly the same turning radius? What about sailplane? How much power does each take? What about the power per pound? I was doing the scaling laws for all these different flight devices, natural and artificial. In my mind, the scaling laws are pretty simple, and while working on that, I thought back about human-powered flight and realized, well, yes, there was a very simple, straightforward way of doing it, which is merely that you can take any airplane conceptually, keep the size the same, keep the weight the same, but let the size just get bigger and bigger and bigger in all dimensions, and the power goes down. And conceptually, you can make it big enough so it can get by on the tiny power that a person puts out.